This is the second exam review video for Chapter 4. Again, we're looking at different forms of equations of lines, so keep your note card handy or your notes page that has the different equations handy. I highlighted number 4, the form they'd like the equation in by the time my final answer is done. So they're reporting and they want it in slope-intercept form. So I want to turn first to that graph in 4a. They identified for me the slope. They also showed me the y-intercept. I can see it. So I should be able to write that equation right away because they provided the slope and the y-intercept. Pause the video and try it yourself. In 4b, they did not provide the slope and the y-intercept. They provided neither one of them. So I've got to first see if I can come up with the slope because between 2 points, I can write a formula and calculate slope. Some of you preferred to put the data in tables. Go ahead. So I'm going to label my x1, y1 and my x2, y2 in my ordered pairs. Slope formula is y2 minus y1. And then in the denominator 7, x2 minus, and again, careful with your negatives, x1. Here's a good time to get your calculator and double check your numerator value and double check your denominator value so that your slope is calculated correctly. Now that I have the slope, you have two choices, but many of you, even though if it said slope-intercept form, many of you preferred putting the equation in point-slope form first and then moving it into slope-intercept form. So I think I'm going to do that. I'm going to keep the 7, negative 10 as my point, and I'm going to keep the negative 2 as my slope, and I'm going to go start my equation in point-slope form, which says y minus the y that you'd like me to use for my ordered pair, slope, x minus the x from the ordered pair. We then would clean this up and move it around into slope-intercept form. So subtract negative 10 with your calculator turns out to be plus 10. Distributing, I have a negative 2x and a plus 14. You can finish this up by solving for that y equals and getting that in slope-intercept form. For number 5, I'd suggest the same thing. For number 5, they'd like your final answer in point-slope form, though, so we have a little bit less that we might have to do. It looks like if we can identify, for number 5a, a slope, and then a single ordered pair the line goes through, that's the information we would want for a point-slope form of the equation. So in number 5, as you look, you can tell that your slope should be negative 2 because they provided it. And they gave you an ordered pair of 2, negative 3. So be sure you're using point-slope form and then clean it up, but do not distribute or move it around. Keep it so the point-slope form exists. So your final equation should look something like y plus something equals, and then you're going to have a number out front and a parentheses full of stuff so that it's in point-slope form. Same in part B. This time they gave you the slope and the point, so you want to go ahead and use point-slope form. Pause the video and get both of those done. Number 6, they would like an equation, and they told us what form, slope-intercept form, so y equals mx plus b. Then they gave us other good information. It has to go through the point negative 2, 2. Has to be parallel to the equation that they gave us. To be parallel, you have to have the same slope but different y-intercepts. So the only thing we take away from the equation that they gave us is we steal its slope. So our equation is going to also have to have a slope of 4 in order to be parallel to that one that I highlighted. But our equation has to contain the ordered pair negative 2, 2. What many of you found handy to do then was to start this off in point slope, y minus the y, slope, x minus the x, and then move this into your y equals mx plus b form of your equation. Pause the video, finish that one up. Number 7 also wants us to do some equation writing, again in slope-intercept form, of a line that passes through the point 4, 2, has to have 4, 2 on it. The line has to be perpendicular to the one they gave us. So what we remember about perpendicular is that the slopes are not the same. The slope has to be 2 things. It has to be the opposite sign and the reciprocal of the slope that we have for the line. So currently, the line that they gave us has a slope of -1. So the line we're going to write an equation for then, so that it will be perpendicular, has to be opposite sign, so positive, and 1's reciprocal, which is 1. So our slope has to be +1 and contain the point 42. Again, just like we did in 6, I'd recommend writing this in point slope first and converting it to slope intercept for your final answer. Number 8, they bring up standard form. So they'd like an equation in standard form that has a certain slope and a certain point. Because they gave us a point and a slope, I would start this in point slope form. Y minus our y coordinate, slope, make sure you include that negative, x, subtract our x coordinate. And once I have that, then I will do the work to try to get it into that standard form, which is ax plus by equals c. And remember, no decimals, no fractions, and that a number has to be positive. So as I do a little work, and I distribute that -2, -2x plus 8. My goal is to have the x's and the y's on the same side and to have the x's be positive. Right now the x's are negative, so moving them would actually help. So if I add 2 x's to both sides, I will have 2x. It's a positive y because there's nothing in front of it. I still have a -6 though. So then I need to do that final work of adding 6 to both sides so that you get your final answer. Number 9. Number 9 talks about making a scatter plot, so I'll get you started, and then the goal is that you would think that one through and finish it yourself. You need to determine whatever kind of relationship exists, so the kind of answer they're looking for here is something about the association. If it's positive association, or sometimes called positive correlation, negative, or no correlation. So please explain whether or not as the years get bigger, does the price get bigger? Positive. As the years get bigger, that the price gets smaller, negative association, or that there's no correlation. Then in part B, they give you 2 ordered pairs and expect you to write an equation for the line of fit. They didn't tell you the form, but I would strongly suggest getting it into either point slope or slope intercept. So the first thing you'd want to do is go calculate the slope, and you're going to need to calculate it because the graph isn't accurate enough to count it. So you're going to want to go label your x1, y1, and your x2, y2. And you're going to want to calculate slope. Then you're going to want to take that and put it into, I would start in point slope form. Y minus, I'm taking my y from the second ordered pair, you'll have a slope, x minus 2003. Okay, and my slope's going to have to go in there. Then move that around. In part C then, you're going to need to use the equation you found in B, predict the price of a ticket in 2009. So we have to figure out what to do with that 2009. 2009 in all of our ordered pairs, or at least the year, was always the x. So you're going to want to take your final equation from part B and C with an x of 2009. You're going to want to find the y value because the y value is going to be that ticket price that you're estimating.